Hello everyone, today we're going to look at the Hello World program and we're going to explain how it works, why it works, and we're going to improve this code so that it is easier for people to read. Alright, so looking at our agenda, first thing, subscribe. Yes, if you would please consider subscribing, I would greatly appreciate it. You can hit that like button, it's more likely, well, maybe that's why it's called like, more likely to show up on YouTube's search algorithm. I always forget to mention this, so I literally have to remind myself, because otherwise I can go on chit-chatting for hours and hours about programming stuff, and nobody subscribes and nobody can find the content. So please do that, or please consider doing that. I can't force you at gunpoint. All right, we'll just leave that there. So going to this program that we have here, I don't think we need this end stuff. That was for TASM. We're using SPASM. So let's get rid of that. And next, if we look at our TI-83Plus include file, we can see that this is already here. So why do something twice when you can do it once? Perfect. All right. Now, I remember looking at tutorials and things in the past, and when I did, we used bcall with an underscore in it. And I thought, well, I wonder if things have changed over the years. So I thought I would use the magic of Git to find out what changes between the files, and sure enough, for one, they added an all caps version. There are underscores in front of each one, well, after the B in front of the rest of it. And I would recommend doing that. I'm going to actually use this newer version going forward so that if you follow along and you want to follow an old tutorial from probably 20 plus years ago now, getting old. But anyway, if you want to follow those tutorials, you can actually just do it without having to modify your code and deal with that extra little headache along the way. Now, I also noticed in this newer version, they added the home up button, which seems like an oversight that they didn't have that before. That seems like something you'd probably want. So if you want that, you can add underscore home up EQU4558H. And you'll notice some green down here. Let's see what that is. It is just a new line. Not super important. All right, so those are the changes I'd recommend you make if you want to follow along. So let's see here. Remove stuff we don't need, update include file, subscribe. All right, so we have included our include file, and you might be looking at this and going, I really have no idea what this file does, besides obviously it makes bcall actually work by doing this other little weird magic stuff for us. What are these things? Well, I have an entire video. It's almost like a cross between vehicle and video. It's a vehicle of understanding. Anyway, it's a video that talks about counting in binary, counting in hex, what a byte is, what a nibble is. And if you want to get all in depth on that, please watch that video. However, if you want the extremely high level short version, you are about to get it. Binary digits are either a 1 or a 0. They are nicknamed bits for binary digit. There are 8 of them in a byte and 4 of them in a nibble. How cute is that? Now, hexadecimal numbers are not just 1s and 0s, and they're not 0 through 9. Like when you're counting, you know the number 10 actually it's 2 characters. You don't hit 2 characters in hexadecimal until you hit the number 16. So it's 0 through F. Why would you do this madness, you might ask? Well, one number in hexadecimal represents an entire nibble. So this 36 in hexadecimal represents, well, not this byte, but it represents an entire byte. All right, I think that covers, let's see, binary, hex, bytes, nibbles, brief, check. All right, why don't we use magic numbers? So you'll remember originally this said 95 or 9D93, I believe. And I recommended switching it to user mem -2. Let's find out about that. User mem 9D95 -2 would be 9D93. Okay, so why do that? Well, it shows you that you're going to be loading this into user memory. Now, we also have this magic number here, which on old tutorials they would use for everything always starts with a T, you'll notice, but 2-byte token. So we're obviously doing tokens with 2 bytes. That might not be that helpful, but the 6D one is, because it is TASM CMP. And if we look that up, TASM CMP, we can see that this is an assembled program. It's an assembly program. So this word actually means something, as opposed to 6D, which I mean, to a computer it means something, and to the operating system it means I'm loading an assembly program. But to a person, that's why we have assembly, so that we can look at words rather than just numbers all day. Excellent. We are moving forward quickly. Next, what is a register? Well, when you get into this, if you've worked with Intel assembly before, or I should say x86 assembly, you will remember MOV for moving a value into a register. LD means load a value into a register. Clever, right? So we're moving 0 into A. In C, this would probably look something like this. So the equal sign basically is a comma, and we're loading it in. Now you might be thinking, where did this A variable come from? Well, it is a register. What is a register? It's basically a global variable built into the silicon of the processor itself. So I remember when I first started programming and I found out about variables and global variables, and I was really excited to use those, because why recreate the same variable hundreds of times when you can just create it at the global level and use it whenever you want, right? Well, there is a downside, and that is you have to keep track of what's in there. Registers are the same way, because they're basically a global variable. Now you might ask, why would you use global variables then? And it comes down to a matter of electronics. The computer needs to know to go somewhere to find the numbers that it needs to work with. So it basically has these little memory banks built inside of it called registers, which is what we're discussing. So there's only a few of them. There's A, B, C, D, there's HL, there's a flags one. We'll get into that more in the future. So we're loading 0 into A, and A is part of the computer processor itself. Next, we're loading A into the cursor column. Well, why didn't we just load 0 into that? That's called an immediate value. 0 is an immediate value. It's not inside of a register. And there isn't the ability to do that, I guess, basically. It's not in part of the instruction set. So we have to load it into a register first, and then we can load it into a memory address. Now, you might be wondering, what's a cursor column? What's a cursor row? If you pull up our little friend here, the calculator, there's a home screen, and there's the graph screen. So each one of these little pixels is a pen column or pen row, and on the home screen, there we are, we have our cursor columns and cursor rows. It's 0 base, so 0, 0 means top left-hand corner. If you change the column to 1, it will move over by 1. Okay, that's handy. Now, why are there parentheses? Well, we're actually working with memory addresses in the RAM. The way the calculator is designed, at a very specific address, there's going to be a value. And the way I picture RAM is generally like a giant locker room, where each locker has a number on it. And each locker actually can hold a byte. And in the case of cursor column, the little locker number is 844C. So in locker 844C, whatever number we stick in there, that is where the cursor will move to on the screen when we run this puts s call. But we'll get there. All right, so why are there parentheses? Well, that's because we actually want to put this value inside the locker. We don't actually want to try to like peel the number off the locker itself and change its number to 0. I'm pretty sure that would not even compile. But we want to put it inside of the locker, and the little parentheses basically mean go inside the locker, and you can either pull values out of the locker or put them into the locker. So there's your little word picture for today. And next we have load text into HL. HL is yet another register. And you might be saying, okay, well, what is the text? Well, the text is right here. If we change this to hello string, we would also have to change this to hello string. You might be thinking, okay, I can see that clearly we're loading hello world with a 0 on the end into HL. And sort of. What we're loading is the address of this. So in the first video, you remember we looked at the hex file, which is, oh, we're on the tracking screen. We want to actually just look at the normal one. I have this little hex editor. If you're wondering what hex editor I'm using, it is the hex editor extension. Very clever of Microsoft to name it that. Okay, moving on. So obviously there's a bunch of stuff in this file, and we can see that hello world here begins at, oh, what address is that? 1632 48 64. It's down there. Anyway, if you find out exactly where this address is located, we would have to keep track of that by hand. As we add more and more code, this address will keep moving further down. And you might be thinking, well, how do these addresses work? This is our locker room in a way. Here's locker 00, here's locker 01, 02, and we just kind of keep counting up our lockers in this little room we have here. And the beginning of hello world is in this locker here, which is where 60 and 01 meet each other. All right, that was longer than I anticipated talking about that, but anyway, we're moving that address into HL. After that, we're calling bcall, which is a block call, and you'll remember we added underscores. And we're calling the puts s function, or system call, which is the put screen. What this basically looks like in a higher level language, like let's say C, is it would look something like this. Puts s, and then it would expect cursor column, cursor row, and then the HL, I guess, technically. And what these would be doing then is it would call this and do all the fun stuff that automatically we want for us. Now, we don't have a way to actually pass these in as parameters, so what we do is we set them ahead of time, and then we call it. All right. After that, we are also going to call new line, which doesn't take any inputs, or I should say any parameters. And then after that, we return to the operating system. We say that our program is done. This is kind of like a return 0 at the end of a C or C++ script. I am going to actually add another bcall. Bcall, and it's going to be clear screen full. And the reason for that is I want to clear the screen so that the assembly program hello will go away before we write hello world on the screen. So parentheses, talked about that. What is a register? Talked about that. Why 0? Didn't talk about that. So the way that the strings work when it does put string, actually I probably means put string instead of put screen, now that I think of it. Interesting. However, when it is running this call for us, it will automatically go through starting at address where the H is, and it'll keep on going until it hits a 0. That's why the 0, because it's basically telling this call, you're done doing your job. Please continue to the next line of code. So that's why the 0. All right, let's assemble it, or let's see if it assembles. And it did. Great. Okay, let's actually put it onto the calculator. So I have my calculator already pulled up here. I need to make sure that it is turned on. And we will throw that into the calculator. We will overwrite the old version. Now we will take a look at our screen. And there's our little cursor. Great. I won't magnify this because it's not like we'll be looking at anything super detailed. So if I refresh it, we have that. And if we run it, it looks like that. So that is success. We officially have a working Hello World program. Again, on our calculator, except this time we understand what it's doing line by line. So I hope you enjoyed this video. I hope you found it educational. Please like, please subscribe. I always forget to say that. I'm trying to say it more now because if you want others to be able to find this content, you can directly contribute without having to pay anything. All you have to do is make YouTube/Google know that it's more popular, and it will be easier to find. So I look forward to seeing you in the next video, and that is all that I have for you today. We'll see you later.